I wanted to talk about the Mantoux test, and this is spelled M-A-N-T-O-U-X, kind of an interesting spelling after a French doctor who popularized it. And another way you might hear this referred to is a PPD or a TST. And what these things stand for is, the PPD stands for Purified Protein Derivative, and actually gives us a clue as to what we're using in this test, which is that we're using specifically TB protein. I'll put that in parentheses. And the location of the test is actually also going to be kind of a clue here with TST. This is a tuberculin, again referring to tuberculosis, tuberculin skin test. So this tells you where we're going to put all that protein, right? We're going to put it in the skin. And you may have seen this, and this is kind of a picture right here of someone doing the test. Sometimes it's referred to as kind of the bubble test. A lot of people say, oh yeah, my doctor injected some liquid in my forearm and it kind of bubbled up, and this is how people usually think about this test. They remember that because it's a very obvious visual. And so what I wanted to do is kind of give you an example or a diagram of what's actually happening when you get this test done. So let's imagine this is your skin layer. This is also referred to as the dermis. And below the dermis is some subcutaneous, so below the skin, subcutaneous layer. And usually in that layer, one of the most common things is fat. So I'm just going to draw that in here. This is the subcutaneous fat. So the idea here is that you're basically putting a little needle in here, which is what you're seeing in that picture on the right there. And that needle is full of some TB protein. So this purified protein derivative is in that needle. It's actually going to be injected in. So you got all these little TB proteins in here. And the volume you're putting in is a small volume. It's about 1/10 of a milliliter, so 0.1 milliliters, and you're putting it intradermally. Intradermally. And this is actually an important point. It's going into that dermis layer. So it's intradermal injection. And what happens is that if you then, let's say moments later, you remove the needle, you throw it away, and now what you're going to notice is that because you put a little volume in there, a little 0.1 mLs, that is going to bubble up, right? Because that volume is going to make the skin puff out a little bit. But if I came back over some time, this protein is kind of diffused over, this liquid has been absorbed into the skin, and that bubble will disappear. So if you come back, you might see a little bit of redness because, of course, poking the skin causes a little bit of redness and irritation, but the bubble will disappear over time. So what are we hoping to accomplish with this test exactly? Let me bring up a couple of more pictures for us. Well, this test is going to help us answer the question of, has the person had prior TB exposure? Just remember that. That's the question we're trying to answer. Have they had prior TB exposure? Yes or no? And let's think about what would happen in either scenario. So this would be that they have not had prior TB exposure. And on this side, let's talk about what would happen if they have had prior TB exposure. So two scenarios. Let's start on the no side. So let's draw our skin again. So this is just as before. Let's draw some TB protein in here. And what's going to happen is you're going to have some macrophages. These macrophages are going to come around, and they're always kind of patrolling the area. They're making sure that, almost like police officers, making sure that there's no problem. And they're going to come and they're going to pick up some of this TB protein. So they're going to take it inside of themselves, and they're going to present that TB protein to another cell. This is our T cell. So they're going to present this TB protein to the T cell, and the T cell is going to say, I have had no prior TB exposure. I don't recognize this TB protein, and it's going to kind of go on its merry way. It's not going to make a big deal about what's going on. So the T cell kind of meanders away. It leaves the area. These proteins over time start to get kind of chewed up and digested by macrophages, and eventually all of it is gone. And if you look on the outside, you see flatness. The skin looks nice and flat. And this might seem very obvious from this picture that of course it looks flat, but that's essentially what we're looking at here is flatness. And looking at this picture, you can see a little bit of redness here, but if you were to feel it with your finger, it would be flat. So it's red, but it's flat. And that's the key. And so this person, we would say, if there was no bulge or bump, we would say this person has a negative PPD. This person right here has a negative PPD. So that's basically how we would read this flat PPD. Now what happens on the yes side? Let's say the person has had prior TB exposure. So same setup as before. Let's draw the skin, and we've got some TB protein. Let me draw that in here. And this TB protein is going to get picked up as before by the macrophage. So the macrophage is going to come by, pick up some of this TB protein, and it's going to, just as before, it's going to find a T cell. And these T cells are also kind of moving around. And this T cell this time is going to say, you know what? I have seen this TB protein before, and this T cell is going to start getting very excited. And this is the key difference, right? It's going to get excited. Before it didn't get excited, it just kind of left the area unexcited, but now it gets excited and it starts releasing chemokines, little chemical messages. And you know what that does? That attracts lots and lots of other cells to the area. Lots of macrophages start coming to the area. They say, aha, interesting, that the T cell tells us that we've seen this stuff before, and this layer, this intradermal layer, starts to swell up with cells. So it's getting full of cells because of all these new macrophages that are being attracted to the area. So this is actually going to start looking like this, full of cells, right, on both sides. So it becomes a nice big bulge, and this is loaded with cells. Macrophages in here, maybe a few more T cells in here as well, but you get the idea. Lots and lots of cells. And we call this a hypersensitivity reaction. So when you see all these cells coming into this area, this is a classic hypersensitivity reaction. In fact, there are different types of hypersensitivity reactions. We would call this a class 4, type 4. And the reason that they're typed out differently is that type 4 in particular involves lots of cells. So this is a very cellular reaction, meaning lots of your immune cells are involved. And you can see that in the drawing. You can see lots of macrophages and T cells in that area. So this is a type 4 hypersensitivity reaction happening here. And if you were to feel with your finger from here to here, it would not feel flat, right? This is not flat at all. This is actually bulging out, and we call this indurated. Indurated, meaning it feels very firm, and it does not feel flat. So this is what you're seeing in the picture here, is that you actually can see from here to here, there's induration. So that's the induration. They're actually measuring it with a ruler. So this is the induration. And you can also see that they're doing it perpendicular to the long axis. So in other words, if this is the long axis this way, they're kind of choosing a 90-degree angle to that, something like that, to measure the induration. So that's how you would measure induration of a PPD. So this looks like a positive PPD on this second picture over here. And we'll get into in just a moment how we actually decide if it's negative or positive. Now, one thing I forgot to mention is that you're going to be reading these PPDs 48 to 72 hours after you initially injected the protein. So 42 to 72 hours later, this is when you actually read the PPD. And that's very important because that gives enough time to either go flat like this or to actually get indurated like that. And one key point I want to make is that let's say you've got redness all the way around here. Do you actually want to measure the redness? No, you want to measure the induration. So just keep that in mind. Induration, not redness, not redness, because they're very, very easily confused for one another, but it makes a big difference, not redness.